Okay, so in the last lesson we talked about carboxylic acid derivative, the acyl chloride, and we saw that the acyl chloride was more reactive than the carboxylic acid. Today we need to talk about another carboxylic acid derivative, and they're called acid anhydrides. Okay, so if I let's I'll draw this would be ethanoic acid. So it's got an OH group stuck to it there. We've already come across the ethanoyl chloride, the acid chloride version of that. So it's ethanoyl chloride. This is ethanoic acid. And here we're going to have, right now, the bit that's stuck on here is it looks more complicated. Right. What it is that. Okay, so this one has got the OH group stuck onto it. This has got the Cl minus, which is stuck onto it, and this bit has got effectively sort of another carboxylic acid stuck onto it. Now all of those three groups they're all electron withdrawing, so in each case you have a delta positive on the carbon there. Okay, and so that means that all three of those will react with alcohols. So I draw you're going to get nucleophilic addition occurring. That lone pair of electrons will go onto the carbon here. Same with the ethanoyl chloride. And the same with the ethanoic acid. And in each case, you're going to get an ester formed. Okay. Now, what happens is this is the worst. This is the worst at reacting with alcohol to form an ester. This is the next best, and this is the best of all. This is the fastest. This is the slowest. This is somewhere in between. So that's all three of the carboxylic acid derivatives that we need to know about, and that is the order. So it becomes faster reaction with alcohol to form ester. So let's see, in each case what we're going to get the ester. So in this case you will get an ester. And the small molecule you're going to get is going to be that H and that OH. So the small molecule is water. In the case of the ethanoyl chloride, you're going to get ester, and you're going to lose that H and that Cl, so you're going to get HCl as the small molecule. And here you're going to get the ester. And what's going to be the small molecule which is eliminated? Well, you're going to lose that H, and then you're going to lose all of this bit, aren't you? So the small molecule is going to be the in that case it's ethanoic acid, but it's going to be the carboxylic acid. That's the small molecule which is eliminated. Right, a little bit more about acid anhydrides. So the structure looks fairly complicated and ungainly, and people do tend to have problems remembering them. So if you get it straight in the first place, you should be okay. So let's have a look at acid anhydrides. Just a little closer look at them. Okay. So why are they called acid anhydrides? Well, you can think of them as being formed from, right, if you get 2 molecules of ethanoic acid, and if you eliminate a molecule of water from there, then you can see, yeah, what you're going to get is the acid anhydride. Right, so if you see quite often, so there's your acid anhydride. Quite often they can be written like this, which is a bit confusing. So it can be written as CH3CO. It can be written like that, particularly when you put it in an equation. In exam papers, they quite often write it like that. You don't need to draw a diagram for it. That can be quite off-putting. People don't realise it's an acid anhydride. If you look at the molecular formula of them as well, so that's going to be C4 H6O3. So if you saw it written like that, yeah, you would be hard pushed at first to think, on earth, what on earth is that? Well, it's an acid anhydride. Yeah. The mechanism of acid anhydrides reacting with alcohols is exactly the same as with the with carboxylic acids or with acyl chlorides. The only difference is that this, instead of the Cl minus dropping off or the OH minus drops off, this bit will drop off as the ethanoate ion. The exam board has said that they won't ask you to draw mechanisms with acid anhydrides. It's exactly the same, nucleophilic addition elimination. I just think having this extra bit on here makes it all a bit more awkward, and they said that they won't ask you to do that. Another point with acid anhydrides is they're quite often used to make esters in industry, right? And let's see why acid anhydrides in industry. Okay. Right, so, well, why? Carboxylic acids, if you react that with an alcohol, the reaction is slow, and you get an equilibrium reaction. So that means poor yield. If you use an acyl chloride, you get a fast reaction that goes to completion, which is good yield. But the problem is that you make HCl. HCl is corrosive. And in exam questions, don't say toxic, say corrosive. If you think in an industrial situation, it might not matter if something is toxic as long as it can be contained. But it does matter if HCl is corrosive, because then you can't use, it will corrode metal pipework and so forth. So it's the fact that it's corrosive rather than it's toxic that is why acyl chlorides are not used. But if you think, right, with acid anhydrides, then you get a fast reaction and no corrosive HCl is formed. Okay, so we'll leave that there for the time being.